Oops. So again, this is my little mini lesson. The full lesson is something we'll cover next time. But I just want to review circumference. Circumference is just the distance around the circle. So if this whole thing was made out of a piece of string, and I cut the piece of string and I laid it out straight and I measured it with a ruler, right? And that's what that is. So it's a length. It's measured in some kind of units, inches, centimeters, miles, something like that. We have a formula. Actually, the definition of pi is circumference divided by diameter in any circle. That's what pi is. So we can turn that around and say pi times the diameter length will give us the circumference. Another name for diameter is twice the radius. So 2 pi r and pi d mean the same thing. You're multiplying that diameter length times pi to get this distance all the way around. And again, I don't think this is new, right? We have seen this before. Yeah? Good. Now, arc length is a piece of the circumference, this little red piece. So instead of getting the whole thing all the way around, I just want this piece. Now, one thing we have to be careful of is not to confuse this with arc measure. We have two things we're talking about. Measure is in degrees. Whoops. Right, we already know if this angle is, say, 60 degrees, then this arc measures 60 degrees. It's different. When I'm talking about arc length, that's like a distance. So there's going to be some kind of distance or length unit associated with it. So this might be, sure it's 60 degrees, but it could be, I don't know, 5 meters or something like that. And a different circle may have a measure of 60 degrees, but it's going to have a different arc length because it's a bigger circle or smaller circle. So they're not the same thing. That's kind of important. This one, arc length, has more to do when you learn about radians, when you take trigonometry. It's working with length. We're working with degrees, so we're the same measure, we use degrees. Okay, so how does that work? What you're basically doing to find an arc length is, if I only want a fraction of the circle, then I'm only going to take a fraction of the circumference. So in this example, this is 90 degrees. So what fraction of the circle is 90 degrees? It's 1/4 of the circle, isn't it? 90 degrees. Now how do I know that? Well, if this is 90 degrees, what's it all the way around? 360. So to figure out that fraction, I would just say 90 over 360. Reduce 90 over 360, and I'm wondering we're not as great at reducing fractions as we might want to be. So do we know, if you see a 0 and a 0, we just have to knock them out. Why do I knock them out when I'm reducing a fraction if I see zeros? What am I really doing? I'm dividing by 10. So whenever you have zeros, you can just get rid of them in both places at the end, because I'm dividing by 10. Now 9 and 36 have a common factor of 9, so that is 1/4 of the circle. So I'm just going to take 1/4 of the circumference. So this circumference, well, let's see, it's 2 pi r, right? 2 pi times 7 is the circumference. Well, I don't want that. I just want 1/4 of it. So again, we can reduce a little bit. That's 2. And 7 pi over 2. That would be just this piece of it. Okay? So arc length, the way you find it is you say, what is this angle measured? Theta here represents the angle in degrees. Divide by 360, that's how I got my 1/4. And then just take your circumference, 2 pi r. So it's a fraction of the circle times 2 pi r. Now the way I've written it up here, this is what I call the exact circumference, because it's in terms of pi. Pi is an irrational number, 3.1415. How long can I be saying pi? Forever, right? It never ends. It's an irrational number. So once I multiply something by an estimate of pi, I'm getting an estimate. So this is exact. If you want an estimate for that, like a number, you just go to your little private calculator, and you would just say 7 times pi. Second button in this little circle is pi. And then I'm going to just divide that by 2. And I get 10.999. It's approximately 11 inches. That is the estimate. Okay, so, and again, I should put my units on that one as well. Inches. Circumference is just inches. Okay, so if I want to find the arc length of this one, would be this on the bottom of page 1 here, I just say, okay, 2 pi r. So what fraction of the circumference do I want? I want 63/160ths of 2 pi My R is 9. Well, that is, let's see, I know that's 18 pi over here. And I can quickly slash out that zeros. And let's see if I can reduce it all. Now, some people are not so good at reducing. So I'm just going to show you how I do it. You can look this way, you can look this way. I'm noticing 6 and 36, right? 6 becomes a 1, 36 becomes a 6. You can also cross reduce. So that 6 becomes a 1, and that becomes a 3 pi. And they don't see what my units are, so whatever that is. Some people have trouble with that. If you don't know how to reduce fractions, another thing you can do is use the calculator. Let me just show you how. Let's say I didn't reduce anything. I've got 60 over 360 times 18 pi. You still have to know how fractions work. Numerators, right? Multiply those over the denominator. So I'm going to leave pi out. Treat pi like it's x or something like that. So it's just 60 times 18 and divide by the 360. And you're going to get a big fraction. Oh no, it's perfect this time. It's good. So that's where I get 3 pi also. Sometimes it's a fraction, so hopefully we'll get one like that. This is the exact answer. If they want to know, well, what is an estimate, you would just take that number and multiply it by pi. Whoops. And then again to the nearest hundredth, unless they tell you otherwise, 9.42. Whatever units you're using. Okay? That's arc length, and that's really it. That's 90% of what you need to know about this arc length. Is that hard? No, not too much. And let's look at the sector area now. This is the other piece. And it's very, very similar, except instead of circumference, I'm going to be working with area of a circle. So area of a circle, hopefully you've heard about this before, pi r squared. We've heard that? Yeah. Okay. Well, you have it. Square the radius multiplied by pi, area, right? Area is like if we fill this with boxes, how many boxes do you need? Which is interesting in a round shape. A sector of a circle, once again, it's a piece of the circle. It's like if this is a pizza, it's a slice. Or a slice of apple pie, or whatever your favorite pie is. So I want to know just this region. Can you guess what we're going to do? What do you think we're going to do with it? Any idea? Well, if I know the whole area, but I only want a fraction of the area, I'm going to do the exact same thing. I'm going to figure out what this fraction is. If I know what theta is, I can figure out what fraction of the circle I have and take that fraction of the area. So it's this fraction, theta over 360 times pi r squared. That's all there is to it. So in this example, I want to know this yellow bit. So find the sector area. Well, what fraction of a circle do I care about? 45 3/60ths times pi r squared. Well, let's see, 8 squared, that's 64, right? And again, we could do a whole bunch of reducing. If I was reducing, I would know that 45 is a factor of 360. And then that becomes an 8. And then I can see that 8 is a 64. I can reduce that. And then all I'm left with is 8 pi. Now this is area. We use square units, square inches. Now, if you're not so good with the reduction, let me put it back to where it was. So again, you're just going to work with these numbers, and you just put it in your calculator. You have two things. You can do 45 divided by 360. Oh, sorry. 45 divided by 360. Hit enter. Times 64. Boom, there's 8. You can also do 45 times 64, and then divide that by 360. That's either way. Yeah, I mean, that's all valid math. So you can try your hand at reducing if you've never done that before. It's a really nice skill to have if you want to go into some math or math-related field like engineering. Make sure you can do stuff like this. And that's it. That's how you do it. And this is really the you try, which is I want you to find the arc length of this, and then I want you to find the sector area. Okay, so give that a shot. And I'm just putting up the answers here. If you want to check your work when you're done, you should have no problem there. And I'm gonna write. Don't look up yet. I'm gonna write how you kind of figure it out first. Don't look. Oh, he's looking. Don't look. See if you can figure it out. Some people are pointing out that I should say 8 times pi. Figure out what the exact number is. So the times. It should be 25.13 approximately. 3 square inches for this one. Is that what you got? Yeah. Alright. That's the yellow bit. Yeah, that's that color section. What would you use if you wanted to get the rest of it? Is it 360 minus 45? On that. So, anyway, okay, great question. But I'm just going back to this one. Hopefully, do we set it up like this? And if you do this right, like this should cancel. That becomes a 6. And here's the 5. So again, I've been doing this 100 years, so I'm pretty good at the, doing it, getting there. For this one, let me just do this one with the calculator. You'll do 60 divided by 360, and then you would multiply times 8. I just want to remind you what you do. If you get an answer like this, press the math button, and then the first thing converts it to a fraction. So there's where the 4/3 came from if you're using your calculator. And don't forget that you're multiplying by 5. So if reducing fractions is not your thing, and you want to use the calculator, you can, and you can use that fraction function to get there. Yeah? Right. And I'll do the other one as well. Cross this out. That becomes a 6. And then this one becomes a 3. That becomes an 8. Yes, sir.
So is it always the radius times 2?
Right. 2 pi r is always the circumference, and pi r squared is always the area of the entire thing. That's always going to be it, and we're just taking a fraction of those values. How did we get close to this? Did we get exactly it? Who gave you get this? Raise your hand. Who is not able to get this? Please ask your question. Anybody? Looks like he wants to ask a question. Oh, okay. You're right, David. Okay, good. You know 90% of what we spent all day doing yesterday. We will go over this some more next class. The homework will not be on this, but I'm going to have to warm up on this next time. So keep these notes handy, and we'll see how we do with it. Any last questions?